and gentlemen, our next session is sponsored by Productivity, which is the platinum sponsor of the conference. The speaker is Adib Ibrahim, who is the Managing Director for Technology Consulting at Productivity. He is the leader in technology strategy and operations practice. Today, Adib will be focusing on technology and digital risk in the fifth industrial revolution era. Ladies and gentlemen, join me in welcoming Adib Ibrahim.
Good morning, ladies and gentlemen. Can you hear me?
Loud and clear, Adib. Go ahead, please. We can hear you.
Excellent, thank you. It gives me great pleasure to be with this audience, distinguished audience of technology and internal auditors across the country, and on an interesting topic as well. This is as I've seen and spoken on this topic a few times before. This is every time I speak, I come across some interesting nuances and questions and thought-provoking discussions, and I look forward to hearing some of your questions as well as we go along. Over the next 50 minutes, I was planning to cover 4 parts of the agenda. First, I would just kind of brief all of us, take us down the history lane on how has industrial revolutions evolved. When we say we are in the 5th era, what was the 1st, 2nd, 3rd, and 4th eras looking like? We would look at what now is the 5th industrial revolution, and how is it different from the existing revolution that we are today, Industry 4.0. How is the risk landscape changing with the advent of the new era, and what does it mean to all of us is the 3rd topic. And then we would conclude with some takeaways that I have observed in the last few months, last 12 to 18 months, ever since I've started thinking about this topic, and would also welcome your thoughts as well. Right. So to talk about the 5 revolutions. So the concept of industrial revolution started in the 18th century, to be precise in 1780 with the first industrial revolution. This was characterized, or this was called the era of mechanization. So machines, factories were getting set up to help drive a lot of production and efficiencies in the economy. In about 100 years from there, we started the journey of electrification. So that triggered a second wave of industrial revolutions, which was called the second industrial revolution. In about 100 years later, we started with the basic computing devices and automation, with the invention, the advent of transistors and diodes, and it was called the era of automation. 30 years later, we are in the era of digitization, where computers and cloud were driving a lot of the economy as we see today. And now we are in the post-digital era. Now looking at each of these, so if you talk about industrial revolution, first industrial revolution, it was largely characterized by the steam engine, so powered by water and steam, you could say. The factories and the mass production kicked off in 1870 with electrification, and that's from 1870 onwards, you have a number of factories that got set up. In the early parts of the 1900s, we've got automobiles also going through the factory and assembly lines as well, and a number of such automations and factory setups drove the world economies at that time. With the advent of electronics and computers, there was a new era of globalization, and one of the things that helped the world was to move work to areas which were more cost effective, and also deliver work more effectively on the services side. Now, and in the world of connected devices, we talk about data, the proliferation of devices itself, the data side as well, and the launch of artificial intelligence in a lot of technologies. And finally, in the post-digital era, which is sort of an interesting times that we live in today, and we are actually at the cusp of that era, is how the proliferation of machines and the way people and men or interact, the man and machine interact with each other, is essentially the hallmark of this era. And what has this led to is we are now looking at new types of jobs. We are looking at some jobs going away. We're looking at new ways of consuming goods and services, and probably even new services and new concepts as well. So, deep diving a little bit more around what defines the fifth industrial revolution and how is it different from the previous one. The fourth revolution was, there are, I mean, among the number of characteristics that we have, I mean, I would probably put down four as primary characteristics of the 4.0, particularly in the last 15 to 20 years. So one is the intersection of the cyber and the physical world. So physical and software worlds are deeply now intertwined, where we saw infrastructure or physical software or physical infrastructure being heavily laden with components such as devices and servers and storage. These are moving slowly into the software-defined world. So you have, for example, even in the IT world, you have networks moving to software-defined. You have data centers moving to software-defined, and with the advent of IoT, a lot of the devices or a lot of the components are actually becoming less infrastructure and less physical and more software. The second dimension is how connected devices are evolving, and you would know that today there are about 50 billion connected devices. That's more like 3 times. So one device per 3 people or even more. And by the end of 2030, it is expected to be around 125 billion. So the rate at which connected devices are growing in the world today is massive and phenomenal. And what that has led to is been the need for new resources, particularly from an infrastructure standpoint, and that has led to the advent of cloud. So cloud is essentially IT as a utility, or IT on tap, if you would like. So computing power is now moving to a utility model, and that's driven primarily from the first 2 trends, which is the cyber physical intertwining and the proliferation of connected devices. And added to this is how machines kind of start learn better. When you have a proliferation, you would want machines to start learning on their own. It's not just rule-based anymore. You can start embedding intelligence that can, if not be like the human mind, at least mimic as many cognitive functions of the human mind as possible. Now, all of these trends is essentially helping enterprises and national economies in 4 areas. One is helping engage with customers better. So traditionally, you needed to be physically together between the customer and the enterprise to service them. And now today, that the distance can actually be filled through online. So you can have digital customer engagements. It is helping organizations make faster decisions in a better way using hard data. And we've helped a number of organizations think through data and how they can use data to inform their decisions. And just the proliferation of data and then the analysis based on that has helped organizations make decisions much more rapidly. The third is how organizations have been able to digitize their services and digitize their products as well. So you can have, to some extent, you can customize a lot of your products. You would have heard the famous saying during the second industrial revolution that you can have any color as long as it is black. This was from Henry Ford during the for the car for the automobiles. Today, the concept of customization has become quite prevalent, not just in the digital world, but actually the concepts of digital world are actually moving into the physical worlds as well. And lastly, these systems and the technologies that we have drive operational efficiencies and performances as well. And this has been the trend for the last 15, 20 years. So this is nothing new, and it's evolving and changing rapidly. But there have been a few things that the speed with which we have developed in the last 20, 30 years has also not without its own share of pitfalls. So while it has given enterprises and nations strategic competitive advantages, in some cases, the human implications were ignored. The human implications of digitization was ignored. Efficiency and effectiveness were the key focus or key aspects that organizations used to focus on. But what that has done is an increase in the pollution levels at hitherto unknown or unforeseen levels now. And the significant impact on climate change has become a very, very real problem today. The agility of the organization has improved or is improving constantly, but then there are socio-technical implications to this. So when I say socio-technical, I would mean, for example, how this balances the work life for employees. What would be the intrusions into the customer information that we have access to as enterprises have access to, and how do the organizations benefit or drive customer behavior using this information. The focus has largely been on the customer, and the workforce has been, I would say, sort of ignored. So the insecurity of the workforce is an increasing problem in the age of machines taking over. And what fifth industrial revolution is doing is also changing how technology interacts with humans. So today we have increasing productivity, there is agility, there is profitability. All of this is actually happening or happening at a much rapid pace than the fourth industrial revolution. So this is continuing as far as the fifth industrial revolution is concerned. And the overall focus on the cost is also kind of improving day by day. But what is also increasing significantly more is the world of mass customization. So we talk about the long tail that helps organizations or helps customers get the most specific requirements to their needs from organizations. But in the physical world, this has been a challenge. And now mass customization with technologies such as 3D printing or even digitization of products, ordering, etc., has actually helped in the era of mass customization. The fifth industrial revolution will be a lot more characterized on climate change, particularly around waste reduction and waste prevention. And this is something that would become a significant focus of attention. It's already kind of started in the last 5 to 10 years, and it's going to gather steam as well. More importantly, in fact, one of the most important part is how does the society evolve? And as you can see from the last 5 industrial revolutions, the spacing between the industrial revolutions have shrunk extremely rapidly. So the first 3, there has been about a space of 100 years, then it's been 30 years, then 10 years, and now we are in the fifth industrial revolution, which the fourth is barely just started. So the global society is also needs to evolve much more rapidly, and this is something that's going to be the focus of thinkers, policymakers, regulators, as well as large enterprises in the fifth, who are driving the spectrum for 5IR. So the forward thinking and bringing an open-minded society, that so open-minded in the concept of adopting or absorbing machines to the workforce, into the ecosystem itself, would become a kind of mainstay. And all this would mean that the collaboration now between humans and systems increase. So the fourth industrial revolution was about software and hardware, if you would like, or let's say cyber and physical worlds coming together. Now the fifth industrial revolution is about the humans and the cyber physical worlds coming together and interacting. So what are some of the shifts in this process, right? So one among these is what the world has increasingly called cobots. Now, cobots are a combination of multiple bots and humans robots combination, um, where there is benefits to be gleaned from machines or robots or specific algorithms. We leverage that, and where there is benefits to be gleaned from the human mind, we leverage that. So the cobots have actually helped embedding robotics into the workforce quite rapidly. Now, the other area is around the digital twinning. Now, digital twinning has been a terminology that has been around for the last 10 years. This helps us manage the physical world or simulate the physical world in the software world or in the digital world. Now, so to give an example, if you want to know where the efficiencies in a manufacturing plant are when you make certain changes, the what if scenarios can actually be done, simulated on the software world, and then the impact assessed, and changes can be made to the physical world based on the models in the digital world. And this is being now expanded to a huge scale. So entire cities are being modeled on in the digital twin world, so that you can look at not just impact of technology introductions into the physical world, but for example, policy changes, behavioral changes, and other incentives, economic incentives that we can provide, and what would be the impact is modeled. The third area is around how do we distribute intelligence in the network. So we talked about connected devices as the fourth industrial revolution, and we said that by 2030 we would have around 125 billion connected devices. Now, what that means is the devices would have computing power. It can be used for intelligence, and in the traditional world, you had enterprises having a central command or central kind of computing structure, which used to be called the data center. And the data center used to have all of the compute resources. Now, data centers are actually becoming a lot more distributed. So you have smaller facilities that can do computing, and these are called edge facilities or edge computers or edge computing centers. So you can have core centers, and then you have edge centers as well. And a lot of the compute requirements and the computing actually happens at edge centers, and only the basic or the most abstracted data goes to the central. So when you have distributed intelligence, you can leverage the capacities, intelligent capacities available across the network to optimize performance, both from the perspective of decision making, as well as in terms of security of information and things like that as well. Now, so distributed intelligence is kind of becoming more pervasive in the fifth industrial revolution. The probably the most defining characteristic is the buzzword or the key focus word was automation in the fourth industrial revolution. Now people are talking about autonomy. We talk about how we can automate a process, and now we can, in the fifth industrial revolution, we're talking about how do we make a process autonomic? How can we make a function autonomic? And this would mean that it is not just about having rules or a specific rule-based algorithms. The algorithms are now more self-learning, just like how would a human being learn. As it gets more data from the real world, it adapts, trains, and grows as well. These are very interesting times that we live in, and it brings its own set of risks. And there has been, and some of these areas are at the bleeding edge of research today. And a lot of academics at both the universities as well as in the country level from a policymakers as well are looking at the long-term implications of some of these areas as well. So let's look at how the risk landscape is changing, right? So in the event of fifth IR, there are many kind of areas that we talk about, but one topic or five kind of key topics that become relevant is the launch or the advent of artificial intelligence. The only way we can start building um, building some of the nuances or the one of the key defining characteristics of the fifth IR is the emergence of artificial intelligence. Now that means it comes with its own set of risks. Um, the compliance frameworks and the ethics frameworks would also need to be relooked at. And all of us are kind of learning on by the day what this means, what the implications are, and the security and resilience was always an important topic, and it will continue to be a very important topic in the fifth industrial revolution. And the same goes for data governance and data protection as well. The fifth area is about the workforce, and we are also, apart from the emergence of robots, we are also seeing some interesting trends in the changing demographics of the workforce, and which we'll talk to in a little while. So, how do we humanize workforce, and what would be the risk categories associated with that? Is the other area that we will be exploring in today's call. So, talking about artificial intelligence, some of the risks that that organizations have to grapple with. AI can be used for even in the best of with the best of intentions. It can potentially be it can have social implications. So, because autonomy is the focus in an AI world and not automation, autonomous algorithms can actually target target individuals a lot more effectively, and it can actually become um, it can actually become quite prevalent or quite difficult to handle. Now, it can also be used to spread information, whether it is true or false. The AI can spread information very rapidly at hitherto unknown speeds as well. And this can have significant social implications. Now, this is on the social implication side, but there are also, at the end of the day, AI algorithms are written and developed in software houses or by developers. And there could be misalignment of goals, and not because of any overt, but it could be just implicit misalignment. So lack of clarity that we set for AI machines, and it's probably not even known to man today on how these um, how these goals needs to be set itself. So the AI powered machines can there is a fundamental kind of area of AI risk called the control problem, which we'll talk about in the next slide, or we'll talk about ethics. But the misalignment of goals is an important area for us to be conscious about. The other area is the unethical use of AI. Now, AI can be used. So there are dual uses. You have concepts, or you have risks such as weaponization of AI as well. and there could also be violation of rights, human rights, human robot rights, and things. So the AI, the risks, particularly related to artificial intelligence on the changing side, or unethical, potential unethical uses, misalignment of goals, and the social implications. Now, what this means is there has been a significant developments on the ethics and compliance frameworks, both at national and international levels. We have one of the most common problems known in AI is called the AI control problem, which is um, actually broken down into two parts. One is how do you align AI or AI algorithms to human values, especially where do you stop to learn, what boundaries do you set in your algorithms from an alignment perspective. And in parallel to that is the second dimension, which is called the capability control. Should we build in the one of the questions that that thinkers are asking is, should we build in um, inherent capability controls to your AI algorithm so that it does not go beyond a certain boundary, and what would be these boundaries? So the AI control problem has been a subject of research and discussion for a number of in a number of organizations and a number of universities as well. And this is going to be the forefront of some of the regulations. Addressing the AI control problem is going to be the forefront of some of the regulations. The other typical problem is biases in your algorithms. So as developers, when they write algorithmic biases, when they write algorithms, how do these biases inherently creep as well? And we may have heard of the three laws of robotics that Isaac Asimov has had postulated about 70 years back, and the machine ethics. And these are increasingly being looked at now. As it used to be fictional 50, 60 years back, and now it's become very, very real. So the need for regulation is essentially on three dimensions. So this has to be, what is lawful and what is not lawful, and there are also, the what is in the gray area. So what cannot be done, what should be done, what can be done, or what may be done. And there has been a number of laws and regulations, policies, guidelines at particularly in the last 3 to 4 years. The second area is around ethics and how do we build ethical principles into the conversation around technology, and how do we give special attention to, it could be vulnerable groups, special interest groups, and things like that as well. The third area is how do you make AI robust and fail safe? You do not have a control problem. It's one area that we talked about, but how do you make it safe and reliable that it can take over even in the event of failures? And as humans, we as individuals and societies have grown to be resilient. The systems in artificial intelligence also would need to focus on that. Now, in all these three areas, if you see how national and international economies have been focusing on, there has been a number of changes. The Center for Artificial Intelligence and Robotics, funded by the United Nations, has monitors a number of such policy approaches that have been launched. If you can actually see in 2016, probably there were three kind of citations of artificial intelligence at the national and international level. In 2017, that went up to 7. In 2018, that went up to 18, and 2019, about 29, including at the OECD level, we have the AI principles, OECD principles on artificial intelligence. We have the United Nations system-wide strategic approach and roadmap for supporting capacity development in AI. All of these talk about, all of these principles, laws, regulations talk about two dimensions. How do we enhance the adoption and usage of AI in terms of both funding and encouraging adoption? And how do we address the risks that AI brings to the world? The most recent was from the most recent is as late as last year, is when the European Union launched the approach to excellence and trust in artificial intelligence, and it talks about how do we address training data, how do we address record keeping in AI, how do we kind of make sure that AI algorithms keep a trail of the decisions that have been made and the outcomes of these decisions as well. How do we provide oversight to algorithms as well? How do we look at what are their specific requirements for specific AI applications as well? So the space is actually rapidly evolving and changing by the day. All of us would need to be cognizant of the of the of the launch of new regulations in this space. Now, so we talked about AI. The security is another important area that that continues to kind of will play an important role, and it's changing from the fourth industrial revolution on three dimensions. One is how do we embed security in an interconnected supply network? Um, Interconnection is a given, so you would need to have new security frameworks for the interconnected network, and this is uh, the previous principles on security was to enable or to fortify your environment. But now, in an interconnected world, how do you kind of keep your keep your systems and information secure? The second is around how do you, given you have now autonomy in your algorithms, how do you maintain integrity? How do you do, for example, things like vulnerability management in your AI algorithms? I mean, there are standard tools and now techniques for source code and vulnerability assessments or penetration tests. But in the age of AI, how do you do vulnerability management or penetration tests? The third dimension is how do you build resiliency? Now, resiliency, the ever increasing reliance on algorithms would essentially mean resiliency will become a lot more pervasive and important. Um, it's not just about black swan events that resiliency would need to be concerned about. It would be every small issues can actually have far-reaching impact on the continuity of the world. So one system down. So how do you bring in resiliency across the um, entire cyber physical human world would become very important. So security and resiliency is the frameworks would change, would need to change with the advent of AI, and all of us need to start exploring new areas. And the I would say the my main submission is to build not so much your areas around um, how do you kind of build how do you kind of build your own framework for security and not wait for standards to come and enforce. So we as risk and audit professionals would need to start thinking about how do we bring in our own kind of risk and control frameworks and um, not wait for regulations or not wait for standards to come in place, because they are usually lagging when it comes to fast-paced economy. Um, the uh, the the fourth area is around data governance and protection. Um, we know that there are 11, 12 dimensions of data governance, and protection, integrity, and access becomes the most important criteria when it comes to data. The changes in the world of data is actually going to drive a lot of um, the frameworks as well. We know there have been a number of decisions, there have been a number of areas that people have started focusing on in the case of data and the types of data that we have. So privacy becomes important, and a lot of economies have now launched privacy regulations and are planning to launch privacy regulations for with respect to, it can be PII data, it can be non-PII data. The digital records of human behavior can actually allow AI systems to predict behavior, maybe even glean preferences, and derive the personal information. Even if PII data is not available, it can be derived from the variety of information that we know or the systems now have access to. How do you protect that information is another. And how do you establish trust in the area of data sharing and data gathering? The second is around quality and integrity. How do we, one of the fundamental problems in AI is the training data sets that are being used. So how do we ensure? So it's not just the quality and integrity of structured data and the currency of how current the data is, but it's also about how relevant the data that is being used to train artificial intelligence algorithms is in the context of the wider world. So the quality of the data sets becomes important as well. Are there biases, inaccuracies in the data itself, and that can actually create issues in the model. And obviously, integrity of the data becomes important. The third dimension is around access to data. How do we give organizations handling individuals' data, or how do we monitor and control the data that exists? And again, one of my strong principles is, we do not have to wait for regulations to come in. This can actually be put in place even before regulations come in each of your respective organizations. Lastly, I would talk about the humanizing workforce. Now, the workforce is an interesting subject for the fifth industrial revolution, because this has not been sort of planned, or the way technologies have evolved is also changing the way the workforce is coming out. Now, you will know, there is Gen X, there is Gen Y, there is Gen Z as well. In the next 3 years, you would have about 15 to 20% of the workforce who are Gen Y, and by 2030, the mix between the three generations of X, Y, and Z will actually be almost equal. So there would be around anywhere between 20 to 30% of workforce of each of these three categories. This is largely because life expectancies and retirement ages are going up, so you will continue to have Gen X in the workforce. People are entering Gen Z, people are entering the workforce much earlier, so you will have a lot more Gen Z in the workforce as well. And you will have the millennials kind of driving a lot of the leadership positions as well in the next 10 to 15 years. So this is one change that is happening on the workforce. The other change that is happening on the workforce side is it's no longer a full-time workforce. So traditionally, we used to have an employer, and there's an employer-employee relationship, and there's a one-to-one relationship between the two. The future workforce would have probably three types. So you would have the traditional full-time employees. You would also have contingent workforces for certain sets of services that the enterprises provide, and there would be people available to do that contingency as well. And then the Uberization of the employment landscape as well. So you would also have the gig economy coming in. Essentially, it is people's skills available using platforms for organizations to take this on tap. All of this introduces its own set of risks that we would not be able to change how the workforce is evolving, but it is important to think through what are the new risks that would come with this changing workforce. With the changing workforce, and how do you kind of address the risks associated with it. And lastly, there is a complex mix of the workforce will include not just humans, but also humans and robots as well. The What this means is, from an organization perspective, you would have new operating models. An operating model is a subject of a very interesting cusp at this moment. How does organizations change? What would be the executive positions? What would be the mix of people? What would be the span of control and things like that? And how would governance work? So operating models would change in the world of in the world of fifth IR. It would require, there would be significant upskilling. I see in the chat that there are some questions around this, which I would just come to in a moment. There would be new roles as well. We're talking about, if you have experienced robotic process automation in organization, and if you have taken that into to to a good scale, you would actually start thinking of, do we need robotics managers or robotics leaders to manage the bots that you have in the organization? And then if that goes beyond a certain level, do we need chief robotics officers, etc.? And then there are also how do, given the gig economy, given the different types of workforce that you will have, there would be antisocial elements that would continue to be looked at or continue to be monitored as well. There was a question around from the audience around what from the fifth industrial revolution, is it going to be a case of robots training humans or a humans training robots? It is. It's actually both. It's not so much. There would be a symbiotic relationship, and then the submission from a fifth IR perspective is that the symbiotic relationship is the most important factor to be considered. Humans and robots need to coexist, and that's where I mentioned you need to have a fairly large or fairly open-minded society to adopt confluence of both humans and robots. Now, the algorithms that we built will be used to train robots. The data sets that we provide to algorithms will be used to train. So it is certainly humans building robots, but also you can actually build robots to help train humans as well. So there could be scenarios on both, and in fact, all of these. So humans training robots, humans training humans, robots training robots, etc. It's important to realize the AI control problem here, which is about in the race towards creating efficient AI algorithms. Are we creating what is now termed as superintelligence? So superintelligence is the existence of an algorithm or an entity that can control everything else as it learns on its own. Right. So the superintelligence is what the at a national and international level we are trying to address or trying to mitigate, putting in laws and checks and regulations in place. There is another question around what new skills do you foresee which will become mandatory moving forward? I'll be honest here. I would have to say, I mean, I would not know, to be honest. So we would all need to discover the new skills. But one constant skill that I would think that we would all need to know is how to learn new technology. So, or how to learn new things. So it's not so much that, okay, we need to learn a new area or a new concept. We would learn to learn. That would be the most important skill that we would require. So if I were to talk about upskilling, it is in the context of every 18 to 24 months there would be a requirement to upskill in the new era, and hence all of us, whether we are internal audits, whether we are in the first line, whether we are in active line of the business, skilling, upskilling is going to be a reality as we go along. So there is no single or a set of skills that we need to know or we need to be prepared for, but the ability to learn is probably what we would need to be prepared for. So from sort of concluding remarks, and I've reached almost the end of my talk, and I'm happy not to take any more questions as well. From an internal audit perspective, I've heard some of these concepts, some of these questions coming up, right? How do we audit uh, digitalization, or how do we audit artificial intelligence? Um, we do not have any programs to audit. We do not have any kind of structured, we call them risk control matrices and things like that. We do not have such programs for digital risk. Um, or in some cases, the organizations may say that they are not yet ready to be audited from a digitalization. Um, I mean, these are the realities in which we operate, but these are changing very, very rapidly. If we were to talk about this subject a year later, this would look completely different, and some of these perspectives may actually look very outdated as well. The fundamental part, I would say, is the framework the principal framework would still remain the same. You would need to know what the risk framework would look like and conduct an assessment of the risk. You would need to know your universe of what areas can potentially constitute audit areas as well, and create work programs on this. We have a clear maturity model that can help you assess your organization's readiness. Um, uh, there is a maturity model that can help you organize or assess the readiness, and it covers around 6 dimensions from a digital age perspective. Your organization's vision and commitment to that to digital, the employees and the culture, the readiness, the organization, the structure and the processes, the communications, marketing and the sales, the underlying technologies and the innovations and development, and the big data analytics and automation as well. So you would be anywhere as an organization, you would be anywhere from a skeptic to a leader, and we have seen maybe 2 years back when we were speaking to organizations, the majority of the organizations would be in the age of skeptic to a beginner. We now see most of the organizations are now in the beginner and follower. In fact, with the pandemic coming in, the organizations have rapidly started exploring and are becoming either follower, or some of them have even reached the advanced stages. Now, there is a question. There is the IIA maturity matrix. Do you think something similar will become a reality for automation in the days to come? Maturity matrix for automation and innovation? Absolutely. Right now, the good thing is there's no standard framework, and which leaves us to be creative and start exploring these frameworks. And I think this is a call to all of us to build the right frameworks, right research, or even kind of contribute to the community around the AI risks as well. There is a lot to be done in this space. This is one of the leading edges in the world of risk today, and there is an opportunity for all of us to kind of create or be the forerunners in the space of creating frameworks for assessment. To kind of close off the conversation today, when you kind of think of these frameworks, there are 4 dimensions. So one is there are industry nuances of fifth IR, and not all industries. I gave a number of examples around manufacturing areas and things like that during my conversation, but fifth IR is penetrating and has penetrated a number of industries, and you would have to look at your industry to determine where you see the applicability of the characteristics of fifth IR, whether it is artificial intelligence, data governance, security and resilience, etc. The second one is around, we talked about the number of frameworks and guidances and policies that have come out across the world. So stay tuned. This is a hot topic. You will find a number of subjects, a number of countries and international organizations kind of setting up guidelines in this space. The third is you would have to relook at your risk universe today. I mean, the risk universe is not just what is visible on the outside. It is not just the systems and the processes that you have. It can actually be a lot more deeper and see how your risk universe kind of changes. And I think last, not the least, is there are a number of buzzwords, and will continue to be there. The fundamentals have not changed, but the fundamental principles will still remain the same. The only thing is, so do not get swayed by buzzwords. And how do we address some of these challenges? So in terms of how do you kind of look ahead? I would leave you with these four thoughts. You would need to see how AI, data, security, and technology are changing your industry, your organization, the universe of your risks. Look at emerging regulations, but do not wait for regulations to come in, and stick to fundamentals as you kind of as you look at this space in the next few months. With that, I would hand over back. If there are, Ninad, if there are any more questions, I'm happy to take.
No, these were the only questions. Thank you so much.
Pleasure, and enjoy the rest of the conference.